Hello and welcome to Inequalities video 1. In this video we'll be exploring the idea of inequalities, some symbols and notation, and just some simple one-dimensional graphical representations. First of all, inequalities will seem a little bit different, and there are a couple of things that are a bit different. Basically, you're dealing with equations, and the rest just falls in place from there. So let me show you first of all the symbology. So an inequality looks like this. 3 is less than 7. It's a statement of less than or equal to. Now we know that this inequality is true. There's some inequalities that would be untrue, such as 8 is greater than or equal to 10. These are the ideas behind. So first of all, we have less than or greater than. And of course we have the greater than equal to or less than and equal to. So that's the notation. The way I like to remember it is that if you're dealing with these inequalities, sometimes you forget what the two sides mean. In all cases, the inequality points to the smaller value. So for example, 3 is smaller than 7 is a statement we're making. And over here we're making the statement that 10 is smaller than 8. Or that 8 was greater than 10. Okay, moving on. Let's have a look at how we can solve simple inequalities. Here's an example. 3x plus 7 is less than 16. This is an inequality we want to solve and see what values f can take. So we solve this just like it was an equal sign. We sort of pretend there's an equal sign there. And there's only one case, which I'll show you in a minute, where it matters that we don't deal with it like this. Let's start by subtracting 7. And we get 3x is less than 9. Then we'll divide by 3. We get x is less than 3. And there's our solution. Now, our second example is 3 minus x is greater than or equal to 1. Now, I'm going to do this example in two ways to really show you and bring home a point. The first way is probably going to be the way that you won't do it in the future. But it really will exemplify why a special rule I'll show you in a minute works. So let's imagine that I had 3 minus x is greater than or equal to 1. The first thing I did was add x to both sides. So this means I'm essentially adding x here and adding x here, which in turn cancels those x's out, leaving me 3 is greater than or equal to 1 plus x. Then I subtract 1, and that leaves me with 2 is greater than or equal to x, or x is less than or equal to 2. So if 2 is greater than or equal to x, then x must be less than or equal to 2. Okay? Now let's go back to the example in its original form and do it the way I expect you probably will in the future. So the first thing you'll do is subtract 3 from both sides, leaving you with negative x is greater than or equal to negative 2. Now at this point, you're going to want to divide by negative 1 or multiply by negative 1. And what that does is it removes the negative sign in front of the x. So let's say I multiply by negative 1. And that will give me x is greater than or equal to 2. But if you have a close look here, well, this said that x is less than or equal to 2. So there's a bit of an issue here. We've got different answers. And it seems like both of our methods are perfectly suitable. So I'm going to tell you the rule now. The rule is that if you divide or multiply by a negative number, you have to swap the inequality sign around. So we actually get x is less than or equal to 2. So if we divide or multiply by a negative number, we swap the inequality. Greater than becomes less than, or less than becomes greater than. Just to make it fair, and you can see why that works. So now I'd like to show you how to sketch inequalities. You'll see here I have a single linear scale, so it's in one dimension. This one-dimensional scale, I'm going to sketch the inequality x is greater than 2. Fairly simple. Now I'm just going to show you how to do this, and I'm going to talk about some of the finer points. First of all, you'll need a scale. So I'm just going to put a 0 here. I don't want to fill up every number in the scale. It's just going to take me too long. So I don't waste too much time. I just put in enough numbers. My 2 is here. So I draw a circle around the point 2. And x is greater than 2, which means that I put an arrow showing that x is starting at 2, it's above 2. Now it's really important here that my circle remains unfilled, because this indicates that it is just greater than not greater than or equal to. So let's have a look at another example. This time, in blue, x is less than or equal to -1. So I pinpoint -1, which is just here. I draw a circle around that point, but because it's less than or equal to, I fill that circle in. So it's a completed circle. And now I draw an arrow going down to show that completed circle, and I have x is -1 or something less than -1. Circle is filled to show that it's less than or equal to. So let's say we had an example where 3 was less than or equal to x is less than 7. So again, I'll mark my point 0. I'm heading down the scale a little bit to the left because I know what's coming. 2, 4, 6, 8, 10. So I need to get 3 and 7 in this diagram. That's why I moved 0 down to the left a little bit. Now here's my 3, and it's x is greater than or equal to 3, so I draw my circle and I fill it in. And here's my 7, but it's not less than or equal to 7, it's just less than 7. So I draw an open circle, I connect the two circles, and this indicates that x is somewhere between 3 and 7. It's greater than, but could be equal to 3, but it cannot be equal to 7 because the circle is not filled. Finally, I'm going to do two quick examples showing what happens when you have inequalities that you have to simplify first and then sketch. So my next example is 2x plus 5 is less than 18. The first thing I'm going to do is divide by 2. So I get x plus 5 is less than 9. Subtract 5, and I get x is less than 4. So now I fill in my inequality diagram again, 2, 4, 6, etc. It's less than but not equal to 4, and I draw my arrow going downwards because it's less than. Last example, this one's a little bit harder. Let's say I had 3x plus 7 is greater than or equal to 5x minus 1. Now I have a tendency to try and bring my x's to the left-hand side. So let's say I took that approach. Minus 5x from both sides, giving me 3x minus 5x plus 7 is greater than or equal to 5x minus 1. And you'll see I've been a little bit cautious here. I don't want to make a mistake, so I've written in that extra line of working. They cancel out. I've got negative 2x plus 7 is greater than or equal to -1. Now I subtract 7 from both sides, giving me negative 2x is greater than or equal to -8. And then I need to divide by -2. Now this is a negative. So not only does this become x, and -8 divided by -2 is 4, but I also swap the sign. So now x is less than or equal to 4. So again, I put my 0, 2, 4, 6, etc. I draw my circle on 4, I fill it in, and x is less than or equal to 4. So that's the basics of inequalities. Just like with equations, you can always substitute in numbers to make sure that they work, but otherwise that's everything you need to know. All the best.